Hello dear learner, welcome back to the Zoom Chemistry Hub. Today we will discuss most important MCQs for all board exam from the chapter Chemical Equilibrium. So first one is at dynamic equilibrium. Option A, the reverse reaction stop. Option B, the forward reaction stop. Option C, both forward and reverse reaction stop, and option D is both forward and reverse reaction continue at the same rate. So in these we know that at dynamic equilibrium both the forward and reverse reactions are continue at the same rate, so the option D is correct. Here the option D is correct, because at dynamic equilibrium the rate of forward reaction and the rate of reverse reaction are continue at the same rate. Next, question number 2. A reverse reaction have the following characteristics, except. In this question, in the 4 options, 3 options are correct while the 1 option is incorrect. So we will choose the incorrect option. So the option A, they proceed in both directions. Option B, they never complete. Option C, product do not form reactant again. And option D is they are represented by double arrow. And in these 4 options, the option C is correct. The option C is correct. The product do not form reactant again. Although according to the reverse reaction this statement is wrong, but in the question the option C is correct, that the product do not form reactant again. Actually in the it is not happened, but the option C is correct. Next, question number 3. The equilibrium constant expression for the given reaction is, we have a reaction, that is nitrogen react with oxygen in a reversible reaction and they form 2NO. And for this reaction we write the Kc form. We write this reaction in Kc form. So in Kc form we know that Kc is the equilibrium constant, and the equilibrium constant is the ratio of the concentration of the product divided by the concentration of the reactant. So here the option A is 2N2O divided by 2NO. Option B is N power 2 O raised to power 2 divided by N2NO. C option N2O2 divided by NO2 power 2. And D option is NO power 2 divided by N2 and O2. And according to the definition of Kc, the correct option is option D, because it is the ratio of the concentration of the product divided by the concentration of the reactant, and the option D is correct. And next, question number 4. The equilibrium constant is the option A, the sum of the two reactant, option B, the difference of the two reactant, option C, the ratio of the two rate constant, and the option D is the product of the two rate constant. So we know that the Kc, which is called equilibrium constant, is the ratio of the concentration of the product divided by the concentration of the reactant. So the option C is correct. The statement is the ratio of the two rate constant. Next, question number 5. When the value of Kc is very small, it shows that option A, reaction will go in the forward direction, option B, reaction will go in the reverse direction, option C, reaction is at equilibrium, and option D, equilibrium will never establish. So we know that when the value of Kc is very small, then the reaction will go in the forward direction. When the value of Kc is very small, the reaction will go in the favor of forward direction. So option A is correct. Next, question number 6. For which reaction the Kc value have no units? Option A, 4NH3 plus 5O2 in a reversible chemical reaction 4NO plus 6H2O. Option B, N2 plus 3H2 in a reversible chemical reaction 2NH3. Option C, N2O2 and in a reversible chemical reaction 2NO. And option D is CO plus 3H2 in a reversible chemical reaction CH4 plus H2. As we know that when the number of moles on both sides, on the reactant and on the other side product, when the number of moles on both sides are equal, as we can see that when the number of moles of reactant and product are equal on both sides, so we can see that in the option A there are 9 number of moles of reactant and 10 number of moles of product, so it is not equal. Option B, in the option B, reactant have 4 number of moles and product have 2 number of moles. They are not equal. In the option C, reactant have 2 number of moles and product also have 2 number of moles. And in the option D, the reactant have 4 number of moles and the product have 2 number of moles, so it is also not equal. So we can see that the option C is correct, because here the number of moles on both sides of reactant and product are equal. So when the number of moles on both sides of reactant and product are equal, then Kc At this in this reaction, the Kc has no unit. So the correct option is C, in which the number of moles on both sides are equal, which are 2 and 2. Next question, question number 7. When the value of Kc is very large, it shows that option A, reaction is at equilibrium. Option B, equilibrium will never be achieved. Option C, reaction move forward direction. And option D, reaction move in the reverse direction. So when the value of Kc is very large, then the reaction will move in the reverse direction. When the value of Kc is very large, the reaction move in the reverse direction. Next question, question number 8. Active mass means option A, the total mass of reactant. Option B, the total mass of product. Option C, the total mass of reactant and product. And option D, the concentration of reactant and product in mole per decimeter cube in a dilute solution. So the active mass is the concentration of reactant and product in mole per decimeter cube in a dilute solution. So the option D is correct. Here the option D is correct. Next question, question number 9. For a reversible reaction, the equation will be the option A is 4C in a reversible chemical reaction 3N plus 2B. Option B, 4C in a reversible chemical reaction A3 and B2. Option C is A3 B2 in a reversible chemical reaction C4. And option D is 3A plus 2B in a reversible chemical reaction 4C. So according to this Kc value, which equation will be? This is the Kc form, and according to this, which equation will be? So we know that in Kc form, the concentration of the product divided by concentration of the reactant. So if we write this into the equation form, we know that the concentration of the product divided by concentration of the reactant. So the concentration of the product, we write this in this way: concentration of the product and the concentration of the reactant. So in this way, the option C is correct. Sorry, option D is correct. Option D is correct. Last question. The reaction between PCl3 and Cl2 will produce PCl5 when the PCl3 and react with chlorine molecule in a reversible chemical reaction. They form PCl5. By this equation, the unit of Kc for the reactions are. What will be the unit of this equation? So we know that according to this equation, first we write this equation in Kc form, and when we write this, the concentration of the product divided by the concentration of the reactant, and as we know the concentration unit is the mole per decimeter cube. This is the concentration unit, mole per decimeter cube. Now we write the concentration of the product and the concentration of the reactant in units. So concentration of PCl3 mole per decimeter cube and the concentration of PCl3 mole per decimeter cube and the concentration of Cl2 mole per decimeter cube. So we got this from this value, so the remaining is 1 over 1 divided by mole per decimeter cube, and when we convert into whole number, whole form, we will get per mole decimeter cube. So the answer is per mole decimeter cube. The option C is correct. So that's for today. If you like this video, please like, subscribe and share with your friends and fellows so we can grow each other. Thanks for watching.